Students, in a group from top to bottom, the ionization energy decreases. The reason is that as the atom becomes larger or bigger, the valence electrons go away from the nucleus. The shielding effect keeps on increasing, so it is easier to remove the valence electrons. That is why the ionization energy becomes lesser and lesser as we move down the group. Here there is a table, or there is a chart or a periodic table which shows the ionization energies of different elements. Students, you can see that there are for example, there is hydrogen atom, and the ionization energy of hydrogen is 1312, lithium is 520, sodium is 495, potassium is 419, rubidium is 403, and cesium is 375. You can see that as we move down the group in in periodic table, the ionization energies are decreasing. Similarly, you can see that lithium has 520, beryllium has 899, boron has 800, carbon has 1086, nitrogen has 1420, oxygen has 1313, fluorine has 1681, while neon has 2080. You can see that as we move from left to right in a period, the ionization energies are constantly increasing, but there are some discrepancies. You can see that here after lithium, beryllium has higher energy, and then after beryllium, boron has little amount or lesser energy. Similarly, in case of nitrogen and oxygen, since oxygen is on right hand side, it should have higher energy, but nitrogen has greater ionization energy as compared to oxygen. We will discuss these kind of discrepancies in detail. Now students, we will discuss the factors which influence the ionization energies. Number one is nuclear charge. As the nuclear charge increases moving from left to right in the periodic table, the attraction in the outermost electron also increases, which in turn will increase the ionization energy. This is just according to the Coulomb's law. According to Coulomb's law, the opposite charges attract each other with certain attractive force. As we move from left to right in a period, then we can see that the number of charges, or the number of protons in the nuclei, are increasing, and because of their increase, the nuclear force also increases. The attraction between the electrons in nucleus also increases, and it will require more amount of energy, hence the ionization energy is also increasing. So you can see, or you will see, that the ionization energy is increasing as we move from left to right in a period, and the main reason behind it is the nuclear charge. Next is atomic radii. Atomic radius means the distance from nucleus to the outermost electrons. So moving from left to right in the periodic table, the radii are constantly decreasing. It strengthens the attraction of nucleus on electrons, increasing the ionization energy. From top to bottom, the size increases and ionization energy decreases. Students, you have seen that the atomic radii are decreasing from left to right in the periodic table, and because of the decrease in atomic radius, the attraction of nucleus on the electron also increases, so they require more amount of energy, and thus the ionization energies are constantly increasing. Similarly, as we move from top to bottom in a group, the size of the atom is increasing, the distance of the electron from the nucleus is also increasing. That is why they require less amount of energy to be removed. Hence, from top to bottom, the atomic radius increases and the ionization energy is decreasing. Next one is called the shielding effect. Students, you may see that the shielding effect is working in a group and it doesn't work in a period, because in a period the number of shell is same, so the shielding effect also is same. Now we discuss the shielding effect in details. The shielding effect plays a significant role in influencing the ionization energies. As you move down a group, the number of electronic shell increases. The inner electron shells act as a shield, reducing the effective nuclear charge filled by the outermost electrons. This shielding effect makes it easier to remove the outer electrons, leading to a decrease in ionization energy down the group. Students, it states that when we move from top to bottom in a group, the number of shells is increasing. The number of shells between the nucleus and the valence electron is increasing. More number of shells shield this electron more effectively, so the nuclear charge also decreases, or the effective nuclear charge is decreasing. Hence the removal of the electron becomes easier. From left to right, the shielding effect remains constant and causes no effect on the ionization energies. Students, you know that from left to right the number of shells remains same, hence the shielding effect doesn't change and there is no effect of shielding effect upon the ionization energies of the elements. Fourth one is spin pair repulsion. You have learned that there are electrons which remain in the same orbital and they have opposite spin. When the spin is opposite, they will have lesser energy or they will be stable, but when the spin is same, then they will be in higher energy state. When electrons are paired in half-filled p orbital, there is electron repulsion, which causes the energies of the electron to increase. The increased energy makes the electron easier to remove, and therefore the ionization energy is decreasing. Students, it states that when there are two electrons in the p orbital or any orbital, they repel each other, and because of their repulsion their energy is increasing, they become unstable. So when their energy increases, then the removal of these electrons become easier, hence the ionization energy of those orbitals will be lesser which have two electrons or a pair of electrons. This will be because of their repulsion. For example, there is a slight decrease in ionization energy in going from nitrogen to oxygen in the second period. As I have told you before that the ionization energy of oxygen is 1313 and that of nitrogen is 1420. Why oxygen has lesser energy? This is because the oxygen have two electrons in its p orbital and which are paired, and because of these paired electrons they repel each other, hence the removal of these electrons become easier, and the ionization energy or the first ionization energy of the sodium of the oxygen is lesser as compared to the nitrogen. Another topic is the deduction of position of an element in periodic table by using ionization energy data. Students, if we know the data that is called the ionization energy data of different elements, then we can determine in which place or in which group or in which period of the periodic table it can be placed. To deduce the position of an element in the periodic table using successive ionization energies data, we can analyze the trend in ionization energies and compare them with the known periodic table. The ionization energy is the amount of energy that is required to remove the electron from a neutral atom resulting in positively charged ion. Here are some key points to consider when using successive ionization energy data to determine the position of an element in the periodic table. Student, this paragraph states that if we have to decide where is the location of an